normally entering into 2D motion. I am entering into two-dimensional motion, and we'll continue with the relative velocity which we started last class in more depth. So topic is relative velocity. So idea is very simple. I was telling you last time. Suppose if I have an observer in the car, so he is the observer, and let us say he is moving with 30 meters per second, and there is a tree which is at rest. There is another car A, let us say, moving with 40 meter per second. There is a car B which is moving this way with 40 meter per second. Let us say there is a car C which is moving this way with 40 meter per second. These are the velocities of the cars, and these are velocities of cars as seen by a ground person. Suppose there is some ground observer. So right now this fellow is observing this fellow, and he is seeing the tree at rest. He is seeing car A going with 40. He is seeing car B going with 40 backward, and he is seeing car C going with 40 that way. Now we want to find the velocities as seen by the observer, this fellow. So what we have to do is, whoever is the observer, first we must bring him to rest. Since he is already moving with 30 forward, we add a negative 30 to him. We add that negative 30 to A. We add that negative 30 to B. And we add that negative 30 to tree. We add that negative 30 to this fellow also, and C also. On doing this, we see that now the observer's velocity became 0. So the motto is bring observer to rest by adding negative of his velocity to himself and also all objects in the universe. So observer came to rest. A is moving with 40 forward, 30 backward. Effectively, it is moving with 10 forward. This car B is moving with 70 backward. This fellow who was standing initially is moving with 30 backward. Tree is moving with 30 backward. Car C is moving with vector sum of 30 and 40, which is 50 in that direction. 50. So the idea of relative velocity is bring observer to rest by adding negative of his velocity to himself and all objects in the universe. If you do this, then you are in the observer's frame. If you do this, then you are in observer's frame. That is the first point. So suppose there is observer A, he has velocity VA. There is observer B, he has velocity, let us say, in some other direction, maybe. Now I want velocity of B with respect to A. Sometimes it is also written as velocity of B like this with respect to A, or simply VBA they write. So with respect to A means A is the observer. So you got to add negative of his velocity, that is minus VA, you must add to himself. So to this VA you are adding minus VA, an opposite vector. And you add that minus VA to VB also. So effectively you get VB minus VA. So VBA is VB minus VA, or VB with respect to A is VB minus VA. We will use this idea. So VBA is VB minus VA. When I say VB, it is with respect to some ground, whatever it is. And VA again is with respect to ground or with respect to any other observer. So this actually means VBA is VBC minus VAC. You can say that as seen by some person C. He may be a ground observer or whatever. If you rearrange this, you get VBC is VBA plus VAC. Just rearrange this term and send it to that side. You get another idea of relative velocity. VBC is VBA plus VAC. Velocity of me with respect to road is velocity of me with respect to bus plus velocity of bus with respect to road. So something like this. We are writing it something similar. Velocity of B with respect to C is velocity of B with respect to A plus velocity of A with respect to C. So whichever way you look at it, I mean the concept should be clear. Bring the observer to rest by adding negative of his velocity to himself and all objects in the universe. Now, what are the kind of problems we encounter in relative velocity? A lot of problems are there. So there are mainly three classes of problems. Three classes. So first class is what is called uh, shortest distance between two moving entities. Shortest distance between two moving entities. This is what we are going to look at first. Then there is also a rain umbrella kind of problem. We will see how to hold umbrella properly. Physics will teach you how to hold umbrella properly. We think we know it, but we don't know. Physics will teach us. We'll see that. Then there is a river swimmer class of questions where can the swimmer directly reach opposite point, or how to cross the river in shortest time and things like that. So we will see all these three. First we shall see shortest distance between two moving entities. This is very interesting, very deep concept also. So before that, before I tell you the shortest distance, let us see one interesting example. We'll build on it. It is related to shortest distance only, but a very interesting example. Suppose this blackboard which you are seeing, the screen which you are seeing is a sea. Screen is the sea, and there is one ship here in the sea which is going like this with 4 meters per second, and its distance from certain point is 4 meters. There is another ship here which is moving with just 3 meters per second, and its distance from same point is 3 meters, like this. So we have these two ships. Let me call this as ship A and let me call this as ship B. So these two ships are as shown and they are going. And above the sea in the sky, there is a helicopter. So there is a helicopter above the sea in sky, stationary. That helicopter is just hanging in midair, stationary. It is not moving. So ships are moving, but helicopter is not moving. The screen is the sea. Whatever screen you are seeing, that is the sea in which the ships are moving. And helicopter may be there above the sea, so somewhere near your eyes, let us say, or near your face, or near your nose, wherever I keep the helicopter. It's just stationary and observing these two ships. Now definitely there will be a collision, no doubt about that. The helicopter fellow is very eager to see a collision between these two ships. Sometimes we are very eager. Suppose we are also worried, but sometimes we want that, you know, oh, accident is about to happen. Come on, let's watch. That kind of thing will be there. If the two trains are coming on the same track, at that moment you are like, oh my God, this is going to be a big collision, and let us see that. So helicopter wala is trying to see that kind of collision between A and B, these two ships. Let me write B here inside and erase it here. Now he knows that this ship A would reach this point in 1 second because there is 4 meters distance and it's coming with 4 meters per second. So it would reach this point in 1 meter. Similarly, this ship, which is at a distance of 3 meters, is coming with 3 meters per second. So in 1 second, it would be here. So in 1 second, both are about to collide. Or if 1 second is too less a time, I'll make them as 4 kilometer per hour and 4 kilometers, 3 kilometer per hour and 3 kilometers. Then in 1 hour, they'll collide. Anyway. Now, collision is bound to happen if they don't change the course, if they don't change the speed, or if they don't change the direction. Collision is bound to happen. So collision to happen after 1 second in this case, to happen after 1 second. Now this is seen by helicopter frame, so I'll say helicopter frame. Now what I'll do, I will go to A's frame. Now that is very interesting. So let's go to A's frame. So how to go to A's frame? You must bring A to rest. So by adding a -4 to this fellow, but you must add that -4 to everybody, including ship B also. You add that -4 to ship B also. You add that -4 to the sea water. The sea probably is stationary, But in A's frame, you must add -4 to the sea water also. This -4 is also added to helicopter. So in this fellow's frame, in ship A's frame, helicopter is also, moving to the left. Okay, now A is at rest. So A is at rest because this +4 and this -4 will add up to 0. Now the thing is, B's velocity, it is now resultant of this 3 which he already had and this 4 which you have added now. So if you make a rectangle or parallelogram, it will be this resultant. That's going to be 5 meter per second because 3 and 4 are perpendicular. So that's like 5. But what is this angle? Let's first get that angle. What angle I am trying to find here? Angle made by the 5 velocity with the 3 velocity. So it's a velocity diagram that I am looking at. Okay, this is a 3 velocity, this is a 5 velocity, and I am looking at this angle. So of course this is 4. So tan phi is 4 by 3 or phi is 53 degrees. So angle made by velocity with vertical is tan phi is 4 by 3. That implies phi is 53 degrees. Okay, so angle made by velocity of B in A's frame with vertical, this is coming out to be 53 degrees. Now what about the line joining these ships? So A and B, I am redrawing them here. I am keeping A at rest now, and B is here. B is here. What about the line joining them? What angle it is making with vertical? We know this is, if you go above, this is 4 meters and this is 3 meters. So I am just writing that here, 4 meter, 3 meter. This is line joining ships. Let us say it makes theta. Tan theta is again 4 by 3, which implies theta is 53 degrees. Please note, previously I found the velocity angle between total velocity and vertical velocity, the direction in which B is moving in A's frame. And now I am finding the line joining A and B, what angle it is making with vertical. If you see, this distance is also 5 meters. The velocity of B was making 53 with vertical in A's frame, and line joining is also making 53. So can I say velocity is along this line? Yes, velocity of B with respect to A is along that line. So I will go like that and collide with A. Now, previously B was going with 3 and he traveled 3 meters. Now B is going with 5 and he is traveling 5 meters. So the velocity is changing from frame to frame. Displacement is also changing from same to same. So displacement and velocity are different in different frames. Are different in different frames. Time is going to be same in all frames. You see here, in 1 second they are going to collide here, obviously. Now also it is 1 second only. You cannot change the time. It cannot happen that in one frame collision happened in 1 second and in another frame collision happened after 10 seconds. If that were correct, then I can avoid collision by going into a different frame. Just by observing from a different place, I can avoid collision. No, that's not possible. So even though velocity is now different, 5 meters per second, displacement is 5 meters, time is still 1 second only. So time interval is same in all frames. Time interval is same in all frames. Of course, this can be challenged from Einstein's relativity, but that happens only when you go very close to speed of light. So right now we are not into relativity. So according to us, time interval is same in all frames. Displacement could be same in different, displacement will be different, velocity will also be different. See, for example, if I am going in a car, uh, according to the driver, I am just sitting there, the distance traveled by me is 0. He will say, sir, you are sitting just behind me, you did not travel anything. But for a person who is outside, I am traveling. Similarly, according to driver, I am at rest. But for outside person, I am having some velocity. So you see, velocity could be different for different observers. Displacement could be different for different observers, but time interval will be same for all observers. This is a very critical point. So So collision in ground frame, he traveled 4 meters, A traveled 4 meters with 4 meter per second. So in 1 second he's coming here. B traveled 3 meters with 3 meters per second. In 1 second he's also coming there. Accident happened. But in A's frame, A is at rest. He did not travel at all. The sea, the water, the river, the sky, everybody is coming towards him. B is also coming towards him. B is coming towards him in this direction. So in this frame, B traveled 5 meters and he traveled with 5 meter per second. But after 1 second anyway, he collided. So time is same in all frames, but displacement and velocity could be different in different frames. Also, one more thing, displacement and velocity and distance traveled is also right. Distance traveled, displacement and velocity are different in different frames. I'm using the word distance traveled. Now let's look at it carefully. There is another quantity which is distance between A and B. Distance between A and B when they collide, that is zero in all frames. So distance between shortest distance between two objects. In our case, they collide, so shortest distance between A and B is zero. Shortest distance between two objects should be same in all frames. Shortest distance. I'm not saying distance traveled, that's a different thing. But shortest distance between two objects is kind of same in all frames. Because if two cars came closest by 1 meter in one frame, they should come by 1 meter in every frame. It cannot be different in different frames. So that's a very interesting thing. So suppose if there are two persons walking on two roads, if they meet in one frame, they'll meet in every frame. That is, their shortest distance is zero. Or if they don't meet, just miss by 1 meter in one frame, in every frame they miss by 1 meter only. Maybe they are traveling with different speeds in different directions, but the shortest distance between them will be same. So this is the idea. So now with these ideas, let us look at one question. Suppose I have two perpendicular roads. So one point is here and it is going with 3 meter per second and its distance from junction is 4 meters. There is another point here which is going with 4 meters per second and its distance from junction is 3 meters. So obviously they won't meet, because you see the point which is moving slowly is at a farther distance. So A, it is moving slowly, B, it is at farther distance from the junction, from O. On the other hand, this other point, if I call it A is farther from O and going slowly. B is nearer to O and going faster. Now the question is, obviously they won't meet. So I want find shortest distance between them. Find shortest distance. Just 1 minute. Hello. అవును మేడం, కానీ నేను చెప్పట్లేదు ట్యూషన్స్. Find shortest distance between them during the course of their motion. So this is the question. Obviously they are not going to meet, but during the course of their motion, I have to find the shortest distance between them. Now there are many ways to do this. So we look at different ideas. One is, you see this word shortest. So whenever the word shortest, greatest, longest, biggest, smallest, when these come, calculus is one of the ways. So we can attack this question by calculus. We'll see that. So we have to find the distance between them as a function of time and then try to differentiate that and equate to zero and all that. Or you can do with relative velocity, where you go into A's frame and try to see how B moves and all that. So I'll just borrow this diagram and we'll see different methods. Okay, let's keep it here. So let's see method one. method 1. This is a straightforward method, nothing to do with relative velocity using calculus. So sometimes if there is no other method and you see the word shortest, greatest, smallest or whatever, maxima, minima and so on, you can use calculus method. So what we will do to, what is it that we want? We want shortest distance between them. So distance is to be minimized. So first you must get the distance between them as a function of some variable. So here time is the variable in physics. So after t seconds, A would have traveled 3t. So the remaining distance of A from O is 4 minus 3t. Similarly, B would have traveled, it's going with 4 meters per second, so it would have traveled 4t. Suppose it came till there. Remaining distance is 3 minus 4t. So now you join both A and B. So the separation between them after t seconds is, if I call delta as the separation, by Pythagoras theorem, this will be this square plus this square under root. So it will be 4 minus 3t square. I'll write delta square, separation square, plus 3 minus 4t whole square. So separation square is given by, and this separation square is to be minimum. Of course, separation is to be minimum, but separation square also can be minimized. So derivative of that separation square with respect to time, because it depends on time, is 0. Okay, so in fact, if you look at this equation, by putting different times, you get different values for delta square and delta. Among that, you have to choose the minimum. So if you draw a graph of delta square versus t, when t is 0, it is 5 meters separation between them. The separation will decrease and will increase. So there is some minimum separation. Their slope is 0. Slope means d by dt of delta square is 0. That's what I am doing. So 2 into 4 minus 3t into minus 3 by chain rule. I am differentiating this with respect to time. Plus 2 into 3 minus 4t into minus 4 is going to be 0. So it is like box square. 2 times box into derivative of box. That's what I am doing. So I can take from here 2 common. If I take 2 common, minus 12 plus 90 minus 12 plus 16t is going to be 0. So 25t is 24, 25t is 24, or t is 24 by 25 seconds. So first I got the time at which the separation is minimum. If you want the separation itself, put it in this equation. So delta square is now going to be, if I put 24 by 25 above, 4 minus 3 into 24 by 25 whole square plus 3 minus 4 into 24 by 25 whole square. That's going to be delta square, which is 25 4 is 100 minus 72 is 28 by 25 whole square plus 75 minus 96 minus 21, but you can square it now. Minus 21 by 25 square. 28 square plus 21 square is 35 square. You can check it by 25 square. So which implies delta will be 35 by 25, 7 by 5 meters. That is the minimum separation between them. That will be like 1.4 meters. You know, many people do the give the wrong answer here. You know, without doing all this calculus, you know what they do. Some students I have seen, they'll do some weird gimmick. They feel that, you know, when this B reaches here, this A would have reached somewhere, and that will be the shortest distance. But no, actually, B may go here and A may come here. This could be even shorter than this, right? We don't know. You can't do that logic. In fact, if you calculate, if B comes here, time taken is 3 by 4. In that time, how much A traveled? Speed into time, 9 by 4. So what is remaining distance? 4 minus 9 by 4. 16 minus 9. 7 by 4. That's what you are getting. But I got a better answer. I got 7 by 5, even smaller. So I got it. So these kind of dirty logics that when he comes there, it will be minimum. When that fellow comes there, this will be minimum. No, it won't work. If you want minimum, then you minimize it properly. There is no other way. You minimize it. Oh, I can't do this. Okay, so that is our idea. Let me erase this. Now let's do the relative velocity method. So I want to just copy this once again. Now I will go into the relative method using relative velocity. Let me just, if I can elongate it. Yeah. So you can go to either A's frame or B's frame. Let me go to A's frame. So I'll add a negative of A's velocity 3. I add it to this fellow also 3. So let me erase this. Oh, I can't erase this. Okay. It's an image now. So it's okay. I'll just take this. So this is 5. So he is basically going in this direction. In this direction he is going. So first we have a velocity diagram here, 3 and 4, and resultant is 5. What is the angle made by this resultant velocity with 4? If you take this as theta, sine or tan theta is opposite by adjacent 3 by 4. So here theta is 37 degrees. So velocity of B in A's frame makes 37 degrees with OB, with the line. What about line joining these two people? Line joining these two people is like this actually. You see that? This is the line joining these two people. That is 5 meters distance. And what is the angle it makes it vertical? It's making a completely different angle. If I call it tan phi, that's going to be 4 by 3, or phi is 53 degrees. That means line joining these two fellows is making 53 with vertical. But the fellow B is going at 37 to vertical. So he is not going along the line joining them. The line joining them, if I show it here, the line joining them is like this. But B is going like that. He is not going along the line joining them. If he would have gone along the line joining them, there would have been a collision between A and B. It is going like this. So this is in A's frame. So A is fixed here, but B is going like this. So A is a fixed point and B is going along a line. What is the shortest distance between point and a line? Perpendicular distance, which I am showing it here. This distance. That is what I want. How to calculate it? I know this angle, that is phi minus theta, because this, sorry, this angle is theta, this angle, and this angle is phi. So this is phi minus theta. This is a 90 degree. I want opposite. So I am using sine phi minus theta is d by 5. Sine phi minus theta. You look at this. Sine of this angle. This is a right triangle. Sine of this angle is d by 5. I can get d from there. So sine of phi minus theta. I'll write it on next page. Sine phi minus theta is d by 5. Now phi is 53, theta is 37. So I have sine 53 minus 37 is d by 5. And sine of A minus B, there is a trigonometric identity. You have to remember this, is sine A cos B minus cos A sine B. So we have sine 53 minus 37 is sine 53 cos 37 minus cos 53 sine 37. That is going to be d by 5. Sine 53 is 4 by 5. Cos 37 is also 4 by 5. Cos 53 is 3 by 5. Sine 37 is also 3 by 5. Is d by 5. 5 gets cancelled. So d, I am getting it as 16 minus 9, 7 by 5. That's exactly what we got in the calculus method. If you go back here, I got 7 by 5 or 1.4. Here I am getting just with some geometry. I am getting it just with some geometry. So if you go to A's frame, B is going in some direction, whereas line joining A and B is a different direction. So there is no collision. So this is the idea. Now, I'll give you one question. I want you to try this. Suppose there is one road like this, there is another road like this, and the angle between these two roads is 60 degrees. Here is person A, he is coming with 4 meters per second. Here it is 4 meters per second, B. So this distance is 3 meters, but this distance is 4 meters. This is the junction. So both are moving but with same speed, but A is nearer to O, B is farther from O. Question is, find shortest distance between them during the course of their motion. Give it a try. I would suggest you do this with relative velocity only, because with calculus this is a bit more complicated. After t seconds, A will be somewhere, B will be somewhere. Then to find distance between them is not going to be that easy, right? So I mean, it's manageable. It still can be done, but it's a bit complex. Okay, where are you stuck, Hamna?
1 second, sir. Sir, I got the answer as 2 root 3 meter.
How much you got? 2 root?
3 meter.
Okay, let me check. I don't know what is the answer. Let me try. Uh, First thing is I'll go to A's frame. You can go to B's frame also. So I'll go to A's frame. I'll add a negative of A's velocity. I'll add that to B also like this. So A is at rest. But I've added 4 by the way. And because this angle is 60, I'm adding in the same direction like this. So this angle is also 60, or rather this is 120. So you're adding 4 and 4 at 120. When you add two vectors of same magnitude at 120, the resultant vector will be at bisector 60 degrees. So the resultant velocity is in this direction. So B is going like this in A's frame. So shortest distance is perpendicular distance. If I were to, this is the perpendicular distance because A is just standing there and B is going along a line. So shortest distance is perpendicular distance. Now it's an equilateral triangle because this is also 60 degrees. So that will also be 60. So side should be equal. So if OB is 4, this should be 1 meter. So that, and this is 60. So this distance will be 1 sine 60. So root 3 by 2. How much you got? 2 root 3. So you get root 3 by 2 meters. This is the fastest way. Or if you go to, you know, A's frame, this B, this is A. A was moving with 4, you add negative 4. B was also moving with 4, you add negative of A's 4. B starts going in this direction. Okay. And this distance was 3. OA was 4, but this is 3. So this is 1. Let me draw it above. This is 1. So, and this is the perpendicular distance. This is 60. So this is 60. So perpendicular distance is 1 sine 60. Root 3 by 2. So root 3 by 2 meters is the shortest distance. Some geometry is there definitely. Equilateral triangle. But this is the fastest method. I'll give another question. Very interesting question. This is a bit more involved as in uh, a bit, a couple of more extra concepts are there, but very easy question. I'm telling you, if you think about it, there is a building like this. This height of the building is h. Let me draw it properly. Yeah, this building height is h. From the bottom of the building, I am throwing a ball with a velocity u at an angle theta, and simultaneously from the top I am dropping a ball. Drop. So this is dropped at t equal to 0. This is being thrown at t equal to 0 with velocity u at an angle theta. Okay. Question is, find shortest distance. If I call this ball A, if I call this ball B, oops. Find shortest distance between A and B during the course of their motion. I'll give you one hint. There are also accelerations here, right? Both are thrown into air, or maybe thrown into the space. Both have acceleration g. So if you look at acceleration of one in the frame of another, that's zero. That means in the frame of one, other's velocity should be constant because its acceleration is zero. So whatever is the initial velocity, that will continue in the other frame. If you want to understand that way, that may be a better way of thinking. Just let me know. అవుతుందమ్మా ఇంకా చదువుకుంటుందా? వెళ్ళు. ఓకే. AC. AC पैसे हो निकलना. Making up. Okay. Answer my question, Hamna. What is acceleration of A in B's frame? Let me ask this. What is acceleration of A in B's frame? Let's start with that. So you see, the moment you throw them, both have acceleration g only, right? Down, because the force was mg, so force by mass acceleration is g for both. So if you want to find acceleration of in B's frame, so you add negative of B's acceleration to itself and also to A. So in B's frame, A's acceleration will be 0. This is an important point. So in B's frame, A's acceleration is 0. That means in B's frame, A's velocity will be constant. Let's write this. In B's frame, A's velocity is constant. But initially, B was at rest and A was moving with U. So in B's frame, A's velocity was U initially in that direction. It should remain the same in B's frame. So in B's frame, A's velocity will be like this only. It's going in that direction in a straight line. So B is at rest and A is going in a straight line. So shortest distance will be perpendicular distance. This will be the shortest distance. Now how to get that? This is theta. So this angle is 90 minus theta. This is 90. So that's going to be theta. If you take this triangle, this will be h cos theta. So shortest distance is h cos theta. This is the answer. H cos theta. You understood this idea, what I am saying?
Yes, sir.
Yeah. These are actually tough questions. I'm just making you think a bit so that, when you encounter them, you'll have some ideas with you. So point is, you can do this relative velocity thing for accelerations also. Now, a very important point here is, uh, mm, I would say, path of one projectile in the frame of other is straight line. This is what we found from this analysis. How? See, both projectiles are accelerating with g. So if you go to one frame of one projectile, other acceleration is 0. That means in the frame of one projectile, other's velocity is constant. Velocity means both direction and magnitude are constant. So in the frame of one projectile, other should be moving in a straight line because neither direction nor magnitude should change. Direction should not change mainly. So it's a straight line. So path of one projectile in the frame of another is a straight line. This is a very important idea. So normally if you throw a projectile, it will go in some path like this. We'll see later that this will be a parabola. If you throw another projectile here, that will also be some parabola. But if you see this Suppose A, in the frame of B, you will see it going in a straight line. That you will see it going in a straight line till one of them lands. After one of them lands, then it's a different issue, because whatever landed, that acceleration became zero, and the other one has acceleration g, then things are changing. But as long as both are accelerating with g, the path of one projectile in the frame of another is a straight line. So that's a very important idea. Okay, next we have what I call as, tomorrow we'll have a class, we'll discuss rain umbrella. One thing is rain umbrella. Morning you are free tomorrow?
Sir, at what time?
9 or 10, whatever is comfortable for you.
Sir, you can take it at 10 o'clock because Samba has taken 9 o'clock.
Then I'll do by 10:15, that will be better.
Yes, sir.
So that you'll have some 15-minute gap. So 10:15 we will do. We'll sit for rain umbrella, how to hold umbrella when it is raining. Then also possibly river velocity, I mean river boat I'll take, river swimmer. We'll do that, and wrap relative velocity and go to projectile actually. Once projectile is done, then some circular motion. Then I'll go to Newton's laws. By the way, what are they doing in your institute?
Sir, kinematics.
Oh, they started kinematics. Okay, that's good. That's good. Okay, cool. I'll send you these files. It's already late, 8 o'clock. Okay, I'll just close it. Huh? We'll meet tomorrow 10:15 then. Done. Bye, Hamna.